we have oxygen gas at 466 Kelvin, what is the average kinetic energy? Well, there's two ways to answer this. It's not specified in the question what we're looking for. So we can answer on a per mole basis or per molecule basis. So two molecules, we'll do both. Get down to the per molecule basis. The per mole basis is 3 half RT. So there's nothing in here that identifies that we're dealing with oxygen, and this is true for ideal gases, that the kinetic energy is not dependent upon the gas present. So it says 3 half times gas constant times R. But what's our gas constant? For the ideal gas law, we use 0.08206. That has units of liter atmospheres per mole Kelvin. That's not the right units of what we're looking for. So we have another version of the gas constant, 8.3145. That's joules per mole Kelvin. So that's giving us what we're looking for, which is energy. Then we multiply by our Kelvin. So Kelvin will cancel with Kelvin. We'll be left with joules per mole for our answer. So this will equal 5810 joules per mole. To get this on a per molecule basis, we're using the same formula, but we're now dividing by Avogadro's number. This will just turn into a per molecule basis. So we have the first part, everything except for Avogadro's, so 5810 joules per mole. So we divide by Avogadro's number, get 9.65 times 10 to the minus 21 joules per molecule. So it's a very small number on a per molecule basis, rather significant number on a per mole basis. For the next question, we're asked to calculate the pressure of nitrogen gas using the Van-der-Waals equation. Not the ideal gas, but Van-der-Waals equation. We have 1 liter of 3.5 moles of nitrogen at 100 Kelvin. For the Van-der-Waals equation, we need to identify the gas now. So our constants A and B are specific for nitrogen gas. So writing out the equation, so we should just make sure our units are appropriate. Moles, liters, Kelvin, everything's appropriate. So we're just going to plug the numbers in and solve for it. So moles, gas constant, same as the ideal gas law, 0.08206. And so our pressure, run that through our calculator, and our pressure is 16.25 atmospheres. So this is the pressure that we're getting from the van der Waals equation. And just for reference, if we calculated pressure using the ideal gas law, it'd be 28.72 atmospheres. So at the 100 Kelvin, we see that we have a significant deviation from the ideal gas law. So the ideal gas law is not appropriate down at this cold temperature.